right, this is 9.4, and we're going to be graphing linear systems. When we graph two equations, there are three possibilities. The most common is you have two lines that touch each other, and then you could also have two parallel lines, and then this one, you only see one line because line 1 and line 2 are in exactly the same place. So, in this case, we say that the system has infinitely many solutions. And in the second one, this system has no solution. And then the next one, this system has exactly one solution, and that solution is at 0, 2. Okay, Salma will rent a car for a day. The rental company offers two pricing options, A and B. For each pricing option, the cost in dollars depends on the number of miles driven. So if Salma drives the rental car 150 miles, which option costs less? So we go over here to 150. Option B costs less. So option B, how much less? Option A is 65 and option B is 50. So the difference is going to be 15. For what number of miles do the two options cost the same? So that would be 100 miles. If Selma drives less than this amount, which option costs less? And that would be option A. All right. Oop, I can't quite see that. We need to graph these two lines. So this one starts at -5 on the y-axis, and the slope is -3 over 1. So 1, 2, 3, 1. We draw that. And then this one starts at -3, and it has a slope of -1, so down 1 over 1. And so you'll draw that with these tools, and it looks like the intersection is -1, -2. All right, I'm going to actually try to draw these. So 2, and then a slope of -4. So I'm going to have to, if I go down 4 and over 1, it's off the page. So I will go up 4 over 1. Let's see if I can connect those. And then the next line, -1, and a slope of 1/3. So up 1 over 3. Okay. So that's my graph. Use the graph to estimate the solution. Write the coordinates to the 10th place. So I need to sort of guess what that is in tenths. So that looks like maybe -0.2, comma, -1.1. And as long as you're close, it will mark it correct. All right. So this is similar to that first problem. So if there is an intersection, then these are called consistent. If there is no intersection, then it is called inconsistent. So this one is inconsistent. If there is exactly one solution, then it is consistent independent. And then this intersection is 3, -2. And if it has infinite solutions, we call it consistent dependent. All right. So it wants us to use the ALEKS graphing calculator. So to do that, you turn on the calculator and you push y equals. And then we go into y1 and we type in the first equation. I'm going to do this for my computer. Negative 2x. I don't see an x on there, so I'll just type x. Negative 2x minus 4. And then in y2, x minus 3. And then we switch from y equals to graph. And then we want to know the intersection. So it wants us to pick the first curve and the second curve, and our guess point is 0. Find the intersection. There it is. Now let's do a new problem, because that intersection was in a weird place. Okay. So y equals negative x minus 3 and 2x minus 1. Graph. Once again, that's let's say that was a 5. Still not enough. Let's say this was plus 3. Okay. So when we click intersection, the first curve is y1, the second curve is y2, and our guess, I'm going to guess 3. And that should move, see how that moved over? You want this blue line to be close to the intersection. Find the intersection, there we go. Okay, so this one here I can graph pretty easily. So up 2, and then the slope is up 1 over 4. Okay. Now, you could convert this into slope-intercept form, but I think the easier way to graph this is just cover the x, and we get y equals negative 5. So if x is 0, we get rid of this term. We have y equals negative 5, so the y-intercept is negative 5. And then we do the same thing by covering the y. Negative 2x equals negative 5. So we divide by negative 2, and we get x equals 2.5. So I'll have to use this, 2.5, comma 0. Plot point. And now we connect those, and we find the intersection is 4, 3. Okay, same thing here, ALEKS graphing calculator, but now we have a bunch of decimals. We do have to put this in y equals form. So I need to subtract 0.55x. So we have negative y equals negative 0.55x minus 4.1. And then I'll just times everything by negative 1. Y equals 0.55x plus 4.1. And then this one, we just need to divide by 0.4. So y equals 2.8 divided by 0.4 is 7 x. And 8 divided by 0.4 is 20. I got Monday brain. 5.4. Yeah. got it right. So plus 20. And then you would just plug these into your calculator. So 0.55x minus 4.1 and 7x plus 20. There's my intersection. So I'm going to change this to -4. And there we go. Okay, that's it. Get to work.